All right, today we're diving into the explosive, colorful, and just plain fundamental world of chemical equations and reactions. Let's get right into it.
So, we've all seen a spectacular fireworks display, right? It's this incredible burst of light, color, and sound. But have you ever stopped to think about what's really happening up there? What is the engine driving that amazing transformation in the night sky?
Well, the answer to that question is a core concept in chemistry. We're going to go from the magic of a sparkler to the actual science that makes it all happen, the chemical reaction. At its very heart, a chemical reaction is all about transformation. You start with certain substances, and through a chemical process, their whole identity changes, and you end up with something brand new. You can really just think of it as a before and after. On one side, you've got your starting ingredients, what scientists call the reactants. And on the other side, you have what you end up with, the products. It's a total shift from one thing to another.
Okay, so if these reactions are happening all around us, how do we even know? How can we spot them? Well, it turns out chemistry leaves behind some pretty obvious clues. Let's figure out how to be a reaction detective.
Two of the biggest clues you can look for are a release of energy and a change in color. You know, energy can be released as heat, kind of like a campfire, or as light, like in a glow stick. And a sudden color change, that's another really strong sign that the stuff you started with has been completely changed.
And wow, it really doesn't get more powerful than this, does it? A rocket launch is the perfect, massive example of that first clue. All that incredible energy pushing the rocket up to the sky, that's all coming from a controlled, powerful chemical reaction. It's a huge release of both heat and light.
So how do scientists actually describe all these reactions? They don't just write down, and then it exploded. Nope, they use this precise, universal language, the chemical equation.
Honestly, the best way to wrap your head around a chemical equation is to think of it just like a recipe. It tells you exactly what ingredients, your reactants, to put in and what you're going to make, your products, when it's all done. It's basically a set of instructions for a transformation.
Okay, I know this might look a little intimidating, but it's really just our recipe written out. On the left, you've got the reactant, ammonium dichromate. That little arrow in the middle just means turns into or yields. And on the right, you see our three products, nitrogen gas, chromium oxide, and water. See the little letters? They even tell us if it's a solid, S, or a gas, G.
Now, here's the most important part. This is a rule that can never, ever be broken in chemistry. It's called the law of conservation of mass. It just means you can't create or destroy matter in a reaction. Whatever amount of stuff you start with in your reactants, you absolutely have to end up with that exact same total amount in your products. Nothing just vanishes into thin air.
You can imagine, with literally millions of possible reactions, things could get pretty chaotic. But chemists are organized. So they've developed a system to classify all these reactions based on what's actually happening.
These are the 5 main categories. So, for example, a synthesis reaction is kind of like building with Legos. You combine simple things to make something more complex. Think hydrogen and oxygen coming together to make water. Decomposition is just the opposite. You're breaking a big thing down into its simpler parts. This whole system helps chemists predict what's going to happen.
So why does any of this matter? Well, because these tiny changes happening between molecules are the driving force behind, well, pretty much our entire world, from huge industrial processes to the smallest things happening inside our bodies.
So, from that beautiful burst of a firework that we started with, all the way to the incredible power of a rocket launch, chemical reactions are the engines that are driving change and transformation all around us, and even inside of us. They cook our food, they power our cars, and they literally keep us alive. I'm going to leave you with this last thought. Right now, as you're listening to this, there are countless chemical reactions happening inside your body, turning your last meal into energy. They're silent, they're unseen, but they are absolutely essential. So, what other unseen reaction is making your life possible right now?